GE 8292 Engineering Mechanics Unit 4 Dynamics of Particles. Hello student, here in this video we will see the Newton's law of motion and related tutorial problems 3 presented by TPGIT Vellore 2. Newton's law of motion. While Newton's law of motion may seem obvious to us today, centuries ago they were considered revolutionary. The three laws of motion help us to understand how objects behave when they are in standing still, when moving, and when force act upon the object. Let's see Newton's first law of motion. What is first law of motion? The first law of motion implies that the thing cannot start and stop or change direction any by themselves. Okay. It required some of force the outside to cause such the change. This property of massive bodies to resist the changes in their state of motion is called inertia. The Newton's first law is also called also known as the inertia of law of inertia. The Newton first law is also known as inertia law of inertia. Okay. Here one object is there. Okay. In Newton first law state that the body at the rest or uniform motion. The body at the rest or else uniform motion will continue to be at rest or uniform motion. It is continue to be in rest or in continually it is moving in one direction. Okay. Until and unless the net external force act on it. Okay. Unless and until the net external forces act on it. For example, this object is still in a rest position until we give the force, it will not move any direction and any places. Okay, still the object is in the same position only and same place only. Okay, if we are giving the some pressure, some force, the object is help with help of force, it will move from its original position. Okay, if the object is at rest, it will stay at rest only. It will stay at rest only unless the net force act on it. Without applying force, the object is still there in the original position. Okay, stay in the original position unless we are applying the force. Here, the object is moving in one direction. It will stay in the motion only unless the force act on it. If we are not applying any force on the object is moving in the same direction. If we are applying the force in opposite direction, the object is again it will change the direction forward to reverse. Or applying the force in side of the object is moving the side direction. Okay, unless we are not applying the force, it is continue the direction only. Okay, this is what Newton's first law. And Newton's second law of motion. The second law of motion describes what happens to the massive body when acted upon the external forces. In massive body, what is happened in external forces acting on the massive body, what happened, that's only described in the second law of motion. The second law of motion states that the force acting on the body is equal to the product of its mass and acceleration. The force acting on the body is uh, equal to the F is equal to mass into the product of mass into acceleration. The Newton's second law states that the acceleration of object as produced by the net force is directly proportional to the magnitude of the net force. in the same direction as the net force and the inversely proportional to the mass of the object. Okay. The next, here the object is moving in one direction with the help of force F equal to mass into acceleration, mass of the object with respect to acceleration. Here we are giving the more force, the object is moving in more acceleration. If you are giving the less force, the object is moving in the less acceleration. That's what's saying in Newton's second law. If you are giving the more force, the object is moving in more acceleration. That is force equal to mass into acceleration. Okay. If you want more acceleration, we have to give the more forces. Okay. Depending on the object mass, the object mass is also considered here. Okay. This is important thing. And Newton's third law. It states that every action there is always the equal and opposite reaction. The ball is hit into the wall, a raw wall or a rigid wall. In how force we are giving into the ball, that much reaction we get from this wall. That is called the every action there is an equal and opposite reaction. Okay, this is the action of force. This is the reaction of force. Okay, the every action has the equal and opposite reaction. Okay, we are applying the force to the spring, and equal and opposite reaction we get as the energy. Okay, the best example is the rocket engine. Rocket engine and air jet engine. These are the best example of Newton's third law of motion. Tutorial problems. Let's see. A force of 100 Newton act on the body having the mass of 4 kg for the 10 seconds. In 10 kg of 4 kg of mass body, 100 Newton is acting at the time of 10 seconds. If the initial velocity of the body is 5 meter per second, determine the acceleration produced in the direction of force. And what acceleration produced in the in direction of force. Because of this force, how much acceleration we will get. The object of the mass also we have to consider here. Okay, 4 kg mass of the object. We are giving 100 Newton into that 4 kg acceleration, 4 kg object. What acceleration should be created? Using the Newton's second law of motion, we will find the acceleration of the object. And next one is distance moved by the body in 10 seconds. In 10 seconds, what distance with using with that acceleration in 10 seconds, what the distance covered that object, or what the distance moved that object, you have to find solution. Let's go for the problem solution. Given data, what are the given data are given? The problem force is 100 Newton, the mass of the object is 4 kilogram, 4 kg, and time is 10 second. Okay, 10 second. The initial velocity of the object is 5 meter per second. Let what are the things to be found? First one is acceleration. Acceleration produced in the direction of force. Second one is distance traveled by the body in the 10 second. In 10 second, what amount of distance the object will be traveled. Okay. First one is the using the equation. Newton's law of Newton's second law of motion. Force equal to mass into acceleration. The product of mass into acceleration. The force is equal to 10 Newton and the mass of the object is 4 kg. Apply directly into this problem. Now we get the acceleration is 25 meter per second square. Uh, with this acceleration, at the time of 10 seconds, object how much distance to be covered? Distance traveled or distance moved or distance covered. Okay, using the motion law, distance moved in given by s equal to ut plus half into at square. Here the distance to be found, initial velocity is 5 meter per 5 meter per second, and t equal to 10 second, and a equal to acceleration is 25 meter per second, and again t is equal to 10 second. Apply all the values into this equation and solve this equation, and we will get the value of distance 1300 meter. In 10 seconds the object moved in 1300 meter. Okay, uh, and go for next problem. We found both the cases. Okay, and go for next problem. The problem number 7. The train of weight 1960 kilonewton start from rest. The start from rest, that initial velocity is equal to 0. The initial velocity is 0, and attain the speed of 120 kilometer per hour in 5 minutes. The final velocity is equal to 120 kilometer per hour, and the time is 5 minutes. If the frictional resistance of the track is 10 Newton per kilonewton of the train weight. Okay, the frictional resistance of the train is 10 Newton per kilonewton of the train weight. Find the average pull required. So find the average pull required to move the train. Okay, what are the pull? What are the force required to uh, move the train? Okay, you have to find the force, and take gravity g equal to 9.8 meter per second. Okay, here go to the solution. The weight of the train is 1960 kilonewton. We'll convert the kilonewton into newton. 1960 into 10 to the power 3 newton, or else 1000 newton. Okay, the mass of the train is mass of the train is this is the mass of the train. This is the mass of the train. You found the mass of the weight, mass of the train into kg form. The weight of the train is given in Newton. You will convert the Newton into mass using the gravity. Okay, mass equal to weight divided by gravity. This is the basic formula. Mass equal to weight divided by gravity. Using this formula, we will find the mass of the train. Mass of the train is 1960 into 1000 divided by 9.8 kg kilogram. The initial velocity of the train is 0, because the train is start from rest. The train is start from rest condition, so the initial velocity of the train is 0. The final velocity is and attain the speed is 120 km per hour. Okay, 120 kilometer per hour. Convert 120 kilometer per hour into meter per second. 120 into 1000 divided by 3600. Okay, we cancel this 0 and 0. Okay, and 0 0, and 1 6 are 6 and 2 6 are 12. Here 1 2s are 2, and 3 2s are 6. Now 100 divided by 3 meter per second. That means 33.333 meter per second. And time in second. They are giving in the time in minutes. That's converted into minutes into second. 5 into 60, 300 second. Okay. Let find the acceleration of the train using the relation uv equal to u plus at, u plus a into t. Using this relation, you will find the acceleration of the train. Okay, v equal to u plus initial velocity equal to 0, and u equal to initial velocity is 0, and final velocity is 100 divided by 3, and t is equal to 300 seconds. Using this equation, we will find the acceleration. The acceleration is 1 by 9 meter per second square. If you are going to examination, you have to aware of the units. for mass kilonewton and weight of the weight newton. Okay, velocity meter per second and time is second. Okay, acceleration is meter per second square. Okay, you should aware of the units of the magnitudes. Okay, and let find the how much second thing, find the average full is required. Okay, average full you have to find. Okay, for this let the average full required in newton. Okay, for this one is the frictional resistance in newton. Okay, in problem they are giving the frictional resistance of the track they are given, and next one is the net force acting on the engine in the direction of motion, the net force acting on the train, the direction of motion. What the force is acting on the uh, train? That means train weight. Okay. Here F equal to net force equal to average full required minus average full required minus frictional resistance in Newton. Okay. Here F1 equal to F1 is frictional resistance in Newton equal to they are given in question. The frictional resistance is equal to 10 Newton per kilonewton of the train in train's weight. Okay, that means 10 Newton per kilonewton of train's weight. That means 10 Newton into weight of the train in kilonewton. Okay, train of the weight in kilonewton is train of the weight in kilonewton is 1960 kilonewton. Okay, 10 into 1960 equal to 19600 Newton. Okay, this is the F1. F1 is frictional resistance value. Now substitute the this value into the equation 1. This is equation 1. F equal to F star minus F1. Okay, substitute this value into this equation. Now using this Newton's law equation, force equal to mass into acceleration. You found the get force equal to F star minus 1960, and mass equal to already we found the mass equal to 1960 into 1000 divided by 9.8 mass into acceleration. Here acceleration is 1 by 9 meter per second square. Apply this value into this equation and solve this equation, and we will get the value of F F star. Okay, the F star means average full required in Newton. The average full is 41.822 kilonewton. This is the force required to pull the train against the resistance, the frictional resistance force. Okay, this is the force, initial force is required to pull the train. Okay, uh, 41.822 kilonewton. Okay, thank you, student. Thank you for watching. If you have any doubt, just comment me. I will give you the reply. Thank you so much and all the best.